Good evening to all of you. Just I am going to talk about this what transmission line, what is the future of digitization and how can improve the efficiency. So every transmission company or other company we have a data. We need technology, innovation and business process. These are the need to digital. Now, we also need this decarbonization, digitization, decentralization, deregulations. These are the buzzwords, but they are really required to make this earth happy. Now, we have by 2030, we have a emission reduction target. It is around 35% of 2005 level, 40% reduction in renewable for total installed capacity. Already we have achieved 28% of 2005 level and already 39% renewable we have installed. So these are the figure which about the India. We are fourth global rank installed wind capacity. We already 179 gigawatt renewable capacity, third largest RE power producer. Wind power 23%, solar 37%, hydro, biofuel, wind power. So these are something which we can proud about the India's. Now about these leaders in energy decarbonization. 38.6 MT CO2 equivalent annual emission reduction through various Unnat Jyoti affordable USD 1 billion energy saving certificate traded. Global ranking among the largest market for green building, 1.4 billion liter diesel we saved per annum through solar power irrigation. And about this power grid, we are not lagging behind. We have also made this digital substation. This is largest digital substation what commissioned on IC 61850 was at Malerkotla. Actually, this was retrofitted, and recently we have another 220 kV digital substation commissioned at Chandigarh. Future roadmap is retrofitting of complete old 400 kV substation in Kanpur. So, advantage of this digital substation, reduce copper requirement, faster commissioning. We can test online at remote station, reduce the downtimes. Already 11 number REMC established by Power Grid at various locations. These renewable energy management center are co-located with the state SLDCs in Tamil Nadu, Karnataka, various states. The renewable energy management center are equipped with the artificial intelligence based RE forecasting, scheduling tools and provide greater visualization and enhanced situation awareness to the grid operators. Deregulation. Our power sector has enabled Power Grid to venture toward new business, smart meter, solar-based generation, tariff bidding, competitive biddings. So, through deregulation, what we can achieve? Yesterday, we have a few large power plant. Now, many small power producer can be there. Centralized, mostly national. Now, decentralized, ignoring boundaries. Based on the large power lines and pipelines, including small-scale transmission, regional supply compensation, top to bottom distribution. Now it is both direction. Consumer decentralization, empowering local communities. Decentralization energy system can use a supplementary measure to existing centralized energy system. Decentralized energy scheme system provide promising opportunity for developing renewable energies, success locally available as well as the expanding access to clean energy, service to remote communities. So this is sometimes grade will be this generation, there will be small scale generation such as solar, wind, hydro, bioenergy and combined heat. transmission grid with a local distribution. Storage can be, this technology such as battery can withdraw electricity from the grid when prices are low, store it and release energy back to the grid when their demand is there. Smart home, customer with generation and controllable equipment. In Power Grid, these are the process. Digitization, we are generate the data that captures system conditions, then communicate, combine this data into various repositories, enable application access, then digitalization, use application to provide actionable insight on the data, use data to create, integrate real-time dashboard, create asset health profile, use cognitive capabilities such as IML tools for informed decision making. Now, digital transformation within the organization, you use augmented tools for objective decision makings, use actionable insight and object decision, augmented tools, access the impact and make tweak to the digital models. So 3D building blocks for the digitization. Power Grid already we are using SAP for enterprise asset management, remote acquisition system for NTMC, we have at Gurgaon, PMU WAMS based grid parameter, PG Darpan, this is transmission line inspection application, that is homegrown application by Power Grid, and QR based data entry for task region. Recently we are just integrating this system to capture all the inspection data through ERP system. Digitalization, use of digitized data to change work, process. PALM, this is the homegrown application where asset health indexing of the transformers and reactors, drone-based patrolling. Amrit, it is also homegrown application, AI-based defect identification in transmission system, augmented reality-based handsets, development of business dashboard, predictive outage management. Digital transformations, adopting through intelligent use of the digitized work process, remote operation from NTMC, 274 substation, they are operated from NTMC at one place, creation of the digital substation, digital work enablement, deployment of asset health management, digital twins for health assessment, robotic inspection of the substation. These are the few steps what Power Grid is already doing and some part we are working. We started in 2010 this integration of online sensor of the substation equipment level. Then in 2014 we have established the NTMC for remote operation of various substations. 2017 GIS mapping of all the power transmission lines. Then 2018 there is automatic fault analysis system, they are embedded in NTMC system. Then 2019 we have developed in-house PALM equipment health indexing card. Then 2020 is a digital substation. Then 2021-22 we have PG Darpan tablet-based patrolling of the lines. Then 21-22 IPS implementation, this is automatic protection system. Then 2023 we have adopted this AML based defect identification in the transmission lines. Now recently we are just beta version is launched where intelligent inspection in Power Grid we are implemented. Leveraging digitization for digital transformation. So in year of 2010 we have SAP implemented, operation from NTMC, creation of AM dashboard such as PALM, PG Darpan. In 2020 we are building on the past development. We have created a dashboard with by integrating OT and IT. We are using augmented reality for inspection and maintenance. This headgear is there, digital headgears are there. We are using for the training as well as remote assistance. AI-based chatbot is there. We are in collaboration with the IIT Kanpur for robot for substation inspection. creation of digital twins and API integration. APM already in process, and within 2-3 months, RFP will become. So this is the NTMC. So what is advantage of NTMC? Optimization of human resources, no shift at any substation. So you imagine we have a 270 station, and in each shift we have to put, suppose let's say 3 to 4 people. Now in place of those, we are centrally controlled from NTMC. Faster restoration in case of tripping through online diagnosis of real-time parameter and disturbance records. Enhance the asset life by ensuring operation of equipment with rated parameters. Safe and secured operation with minimum human intervention and interlock applicability in multiple stages. Enhance reliability, centralized real-time monitoring of the release. So these are the advantages what we are getting from NTMC. Already we have Center of Excellence for Control and Production Systems. Establish remote access of the all production relays and SAS of substation from NTMC. Centralized management of the production SCADA system, configuration, troubleshooting and providing support to site during the commissioning of O&M, uniformity of configuration in IDs and SS, management of patch, firmware, anti-firmware upgradation of IDs, SS, remote audit of IDs and SAS gateway. These are some view of this application what we have developed, we are using. This is UDAN, this unique digital assessment of the asset network. So here we see this left hand, we have all assets, they are integrated with the SAPs. So all asset is dynamic in nature. Whenever some asset is added, it will automatically update. We have a certain KPIs there with what we have managed is availability and tripping per line. It is a automatic updated when data has put into SAP backend. Then annual maintenance plan and transmissions. So these are dynamic, it is coming from the SAP data. And right hand, we have some daily operation data. We are taking this data from NTMC through OT and IT integrations. We have also critical equipment we are monitoring in one page. So this is something bird view. At one page we can get what is going inside the organizations. This PowerGrid Asset Life Management System PALMS. So web-based portal developed in-house for real-time health assessment, more than 3,600 transformers and reactor. So we categorize all these assets according to the health indexings. Advantages, risk-based severity index of transformer reactor, dashboard for monitoring of critical equipments, age assessment model integration is done, dynamic aim scheduling on severity grade. This is the PG Darpan, what I talked about. This is the homegrown application. We have more than 2.75 lakhs towers are there. We are monitoring through this app. This is the automatic identifying of the defect or person when they are going for inspection of the transmission line, they are capturing the photograph, its specified direction, then it is processed through the software search engine, and if any defects are there, almost more than 35 defects, they are identified through this model. So this is the asset management concept from run to fail to time based, usage based and condition based, then predictive, then reliability centers. So during past we have just improving ourselves, and now we are going for the reliability center maintenance. So the basic concept in reliability center maintenance is presently what we are maintaining our asset on the basis of the health model. This health model, all these testing parameters we are capturing and storing in the ERP system. So the data source is ERP system. Asset failure data. So there is a degradation model is there. From degradation model and health indexing, we calculate what is the probability of failure is there. And last one, presently it was not used, impact model. So if any asset it is failed, what will the impact on the grid? So that is coming into picture. for reliability center maintenance, and on the basis of all this input, we are creating a risk index. So individual maintenance plan for each asset, not asset class, but each asset depend upon their criticality and importance of grid operation. Predictive maintenance tool need to be fully operational to facilitate timely planning, minimize schedule outage. One of the key outcomes for RCM is the failure mode analysis. When done correctly, the outcome should be informed that may alter the maintenance approach taken to date to try to avoid future failures. For example, the interval between the inspections may be shortened or lengthened, or the threshold of the tolerance for condition rating might be raised or lowered. What Power Grid? We have adopted this two-axis model for risk. Vertical axis, it is the probability of the failure is there, and this horizontal axis, it is the impact of the failure. Accordingly, we have categorized in 5 categories, and on the basis of categories, we are categorizing the inspection cycle or maintenance cycle. Suppose, let's say, one asset, it is in healthy condition, and failure of those asset is very less impact on the system. So we take those on stable condition. And in category 5, suppose health condition is also poor, or probability failure is very high, if failing is very, impact is very high. Suppose, let example, there is a 2 transformer is there. One is connected to the, let's say it is a NCR area, it is feeding the power. Maybe it is a metro, and another similar equipment, it is connected to some other places where it is not connected so critical load. So now maintenance philosophy, according to that, if any, we will more take care about the asset which are connected to critical loads. So they are in category 5. We have made this all 3600 transfer reactor, we have categorized in our organization, and these are just a map of these transfer reactors. So output of RCM, this real-time health indexing along with the risk impact mapping. This will also lower the maintenance cost. Inventory optimization, we can not only optimization, we can also decide where inventory to be placed. Then optimize resource planning, data-driven decision making. So what we have conceived that for transmission line inspection, we can reduce by doing this 23% manpower we can reduce. For substation maintenance, we can reduce the 38% manpower reduce. These are the factors which are shaping future electricity grid, generation, scheduling, intermittent natures. So forecasting technology, these are the wide is a factor, and this red is challenge and action. So for scheduling, for this already, for in our case, we have NTMC, we have operation data are there. So we can predict the when our loading of the transmission line or ICT or connector, there will be in a lace. So we can plan the AMP plan during this off-load condition. Flexible capacity, maintaining grid parameters. So storage capability action can be taken. Distributed generation, two-way exchange of the power. Two-way exchange of power means suppose we can say the solar installed at the rooftop can be just communicated to other end. So implementation of smart grid technology. In case of transmission, infrastructure, congestion, curtailment, load setting, planning and capital infusion can be done. Cross-border interconnection, financial, political, technical aspect, multiple arrangement and implementation. Accessibility, electrically mobility, adoption and vehicle to grid integration, initial subsidies and charging infrastructure, electrical cookings, awareness and cost effectiveness, distributed electrical capacities, digitization, cyber security, threat to external factor, capacity building at institutional level, that action to be required, and grid resilience to avoid grid failure, effort toward the anti-fragile grid. So for Power Grid, this grid resilience is more important for where we are going for digitization. So all assets we are mapped, digitized, and visualization can be done. So any, let's suppose there is cyclone is there. So we identified in advance what are the assets they may be affected. So we can take the mitigation action according to that. So electricity grid in 2050, it may be like this. Electricity as the main energy carrier, digitized, secured and resilient grid, globally interconnected grid, inclusive and universally accessible grid. Thanks for hearing me.